There have been a ton of questions about that Revo hacking video. I didn't show you what led up to hacking that Revo hubless bicycle, and to keep things on topic in the video, I didn't provide a lot of context about my background. So naturally, when I started reverse engineering that thing, some people were like, hey, who helped you do that? Was there like an engineer standing at a frame? It looks from the outside as if my capabilities magically doubled overnight and that I'm hiding something. Everybody knows there's no such thing as magic. Certain things were clear from the video, like the fact that I use an LLM for certain coding tasks, but even that doesn't tell the whole story. So how did I hack the Revo, and did I have a secret engineer sitting outside of the frame like chained up or something? Well, let's review exactly what it is we're talking about. The Revo is a hubless e-bike with a host of dumb features that only work with a smartphone app. The product failed, the company vanished, and the app is now unsupported. The Revo is the perfect example of appification gone awry. So I borrowed a Revo, took it apart, tapped into the brain, hacked it, and installed a screen that controls all the features that were once reliant on the app. End result? It works like other e-bikes now. You can see your pedal assist level, your speed, control the headlight, and even some other features you wouldn't find on almost any e-bike, like the turn signals. And it does this with a $22 screen and a 3D printed enclosure. Now, of course, people loved this because I de-appified something that desperately needed de-appification. But it was genuinely confusing to some how I was able to do this myself. Even longtime viewers that know a little bit about my background were perhaps rightly skeptical. So let's talk about what this project actually entailed, what my knowledge gaps would be, and how I filled them in such short order. Well, first, there's general bike repair knowledge, which I have covered, of course. I wouldn't be running this channel if I didn't. Then there's knowledge of e-bike topology. The battery, motor, speed controller, pedal assist sensor, wheel speed sensor, all the stuff you would expect to find on a normal e-bike. I'm pretty well versed in e-bikes and working on them, and so there are no knowledge gaps there. Then there's the electrical technician stuff, we might call it. We'll just call it ETS for short. That's all the analog stuff like voltage, amperage, relays, diodes, DC, AC, the use of a multimeter, soldering, everything the guy who fixes your air conditioner should be well versed in. I was a 12-volt technician in my early days, working on everything from car audio systems to alarms and remote car starters. Okay.
Like you've been doing this every day for the past month.
Installing something like a remote car starter on a luxury car in the mid-2000s would involve the ignition system, the immobilizer, door locks, climate control, and even little gremlins like certain Toyotas would leave the headlights on and drain the battery after the remote starter timed out. And so you need to like trick the car into thinking the driver door opened and closed after it shut down. Working in 12 volt taught me about relays, CAN bus lines, entertaining the whims of picky customers with way too much money, and most importantly, it taught me how to not fry the BCM in some lady's BMW. Because of that professional experience in 12 volt, I was able to focus on the actual task of hacking the Revo. All the other stuff like the power delivery, testing stuff on the board and not burning it out, the EL pad, all of that was second nature. I'm already up to speed on it. So on to the next one, 3D modeling, which I used to fix the plastic body and to create a screen bezel. I learned to 3D model when I was 13 years old in a program called Bryce 3D with a process called Boolean modeling. You basically take things like cylinders and cubes and spheres and just kind of stick them together. You can also use negatives of all of those shapes to create cuts. It's actually pretty limited, and I've had such a difficult time trying to unlearn Boolean computer modeling that I've all but given up. And so I just use Tinkercad for everything. It's a free Boolean modeling program that just runs in your browser. And I use it for almost everything except for fillets, which are like bevels and curves on the corners of things. So I'll make it in this primitive Tinkercad software, and then I'll move it into Fusion just to add the fillets. Something like this is just a combination of a bunch of squares and circles and then some text, which you can just type out and make a negative of to make the cuts. And then I can just connect them together so that it's almost like, you know, a stencil. So we've got most of it covered. Bike repair, e-bike topology, ETS, and 3D modeling. Those are all areas where I have at least just enough expertise to tackle a project like the Revo. And it's like 80% of it. So my knowledge gap is somewhere in the final 20%, which involve the actual hacking and the subsequent coding of that cheap yellow display. So let's start with the coding. Indeed, there were Python scripts running in terminal to capture the Revo's data. And of course, that screen, which had a whole user interface and everything. I made no secret about my use of an LLM to do that. Whether it be Claude, Codex, or any other coding agent, you can just ask an LLM to write code for you, and it'll do it. Your uncle, whose computing knowledge is limited to Candy Crush Saga, could ask an LLM to build him a Candy Crush Saga game, and it would do it for him. And in the minds of some commenters, that's what I was doing. Maybe some of you have heard of the acronym GIGO. It stands for garbage in, garbage out. What a computer gives you is only as good as what you give it, and this is more true than ever before. Now, the code for that screen was written in C++ and then compiled down to machine code, which looks like what you would see in like The Matrix. Everybody's seen that movie, and there's all those zeros and ones on the screen. That's machine code, and I have almost no experience that far down the stack. Something that I understand, like JavaScript, has many layers beneath it before you get to the stuff talking directly to hardware. And the vast majority of people who you might consider coders are only experienced with the very top of the stack. So when I see comments like, "Hey, did you have a qualified developer look over that code?" I know many actual programmers, and I showed a few of them that video. And none of them asked me if they could look over my code base because they always have terminal fired up. They can just type in git pull and they can just see it. And then they would come with receipts. Then they would say, "Hey, Seth, you have a syntax error on line 347. In 1993, my parents bought a 66 megahertz gateway desktop computer that booted to a black screen with a DOS prompt. You would then type in WIN and press enter. That would get you into Windows where you could use America Online or play Jazzball. Well, at a certain point when I was 9 years old, my parents turned the computer on, and instead of that DOS prompt appearing, it booted directly into Windows without anyone having to type in WIN. That's because I edited a batch file. It was called autoexec.bat. It just executes DOS commands line by line. I made a new line and added win to the end of it, and I saved it. It was on like a blue editor that was in DOS. That's the simplest modification of code that anybody can do, but it was the first time I actually used computer code to do something useful, and I've since continued to dabble in code. And in fact, for about 10 years, I had clients who trusted me with their websites, online stores, and sometimes everything at their company. I've done database migrations and even some light forensic stuff for court cases. I've worked closely with all kinds of IT professionals, including programmers of all kinds, web designers, UI designers, and the guy in the IT department that won't make eye contact with you. I was a generalist. I was never a good programmer, and I most certainly never knew the first thing about C++. But I have a leg up over your Uncle Candy Crush. Certainly enough to explain to Claude what hardware this thing is and what to do with it. I felt comfortable vibe coding it and making the repo public precisely because it's a silly little project involving a $22 part and an e-bike that almost nobody has. The throttle is analog and it goes directly to a different piece of hardware. The throttle cannot be engaged by the Bluetooth controller. This screen can't hack your bank account or make the bike take off on its own. But I did review the code base manually myself, specifically to ensure that none of my personal information got snuck into it somehow. So that's all I have to say about that particular knowledge gap. I have a background in computers. I don't know how to write C++. I use an LLM to do it, and I'm pretty sure it's not going to kill anyone. So now we move on to the final piece of the puzzle, the final knowledge gap, electrical engineering. It might be a stretch to call it that, and it might not even be the right term, but it came up a lot in the comments, and we're of course referring to the actual hardware here, in particular the digital stuff. The BLE chip, the UART headers. I was doing things I had never done on camera, and indeed, my reaction to seeing that code pop up on the screen was exactly the kind of reaction you would expect from someone who doesn't do it every day. All right, I'll do you one better. All I have to do is change the 4 to a 5, and it should turn the light off. And that means all my commands are correct here. instantly. This was not business as usual at Berm Peak. This was a breakthrough. You were watching the knowledge gap closing before your eyes, but I can't say I didn't prepare for it. I've been messing with this stuff pretty heavily since last year, studying it, accumulating tools, and learning what is possible. And in January, I started thinking about all the unfinished business I had with the Revo. The more I thought about it, the more I realized that the information I needed was probably obtainable through that little serial interface. And the fact that I could use an LLM to write Python scripts and things that would take me forever to do line by line, I realized there was a very good chance I could hack the Revo. And so I went in search of a Revo, and that's how I met Brian from Citizen Cycle and borrowed his bike. I borrowed this one from a viewer, and like other Revos, it had a laundry list of problems. But I did go into that hacking project with a false sense of confidence. I was like 100% sure I was going to hack that thing. And in hindsight, I wouldn't have had a prayer if it wasn't for one thing, something I showed all of you. It was all labeled. I would have been sitting there with an oscilloscope, listening to that whining noise for hours, and I would have had no clue what the BLE chip even looked like. And in the end, I might have torn out all the electronics and installed a normal e-bike controller, manually wiring up the kickstand servo and the light and everything else to normal analog buttons and switches. I would have gotten it all to work, and most certainly it would have been a hack job, just not actual hacking. So what now? Can I hack, let's say, a specialized e-bike, maybe the Bronco bike? I'm gonna try, and I'll probably fail. But if I succeed, it's because I had the perfect beginner project to learn on. It was out on a silver platter for me. And indeed, without LLM coding, this would take me so long, it wouldn't even be worth doing. So hopefully knowing a little bit about my background, the history leading up to the Revo project, and why those markings were so important gives you a clear picture of what you bore witness to. And I hope knowing how the sausage was made didn't ruin any of the magic. But I'm not really about magic. I want you to know what's actually happening. And so hopefully I didn't bore you to tears explaining it. Thanks for riding with me today, and I'll see you next time.